So I'm back within Pro Profs quizzes with another review of the practice questions which are on there. So this one was done by somebody called Houseboat Billy. They've had 63,925 attempts. It's 14 questions and it was just updated last month. So hopefully we should be all up to date. So as ever, we'll go through the questions. I'll give my opinions and we'll see if we agree with everything that's there. So question 1. Which welding procedure is safe to perform in wet conditions? Okay, an interesting one straight off the bat. So what we've got oxy welding, arc welding, MIG welding and TIG. First off, this term of arc welding doesn't sit well within the theory of you learning process names. Okay, arc welding is anything that uses an arc, but it's colloquially, or common, it's used for MMA welding. So we'll go with thinking he probably means MMA welding. Wet conditions. What are wet conditions? Am I standing in water? Or am I welding on top of water so the plates are wet? I don't think any of these are good in wet conditions because they're all going to have similar type of issues. We're going to be heating up a weld pool where if we weld over water, we're going to have porosity or something like that. We could say that potentially oxy welding is going to evaporate the water off if it's on the plate. I don't know. I'm going to go with that because my logic, these are electrical processes. This is a non-electrical process, and away we go. Right, so I'll submit my answer. What we got? Right. Said I'm right. Great. Why does it say I'm right? Oxy fuel is safe to perform in wet conditions because it does not require a shielding gas like MIG and TIG. Oxy welding uses a mixture of oxygen and acetylene gas to create a flame, which is not affected by moisture. What does it matter? The arc in TIG welding is not affected by moisture in the shielding gas. It's the weld at the end is affected by moisture. So, okay. On the other hand, arc welding, MIG welding and TIG welding all use shielding gases to protect the weld from contaminants, and the wet conditions can interfere with the effectiveness of the shielding gas, potentially compromising the quality and safety of the weld. Yeah, I think that's a terrible justification for the answer. I would say that nothing should be used in wet conditions. We should be drying all of our plate, have good workmanship standards, doing all that. If you've got to weld and there is a high degree of moisture, maybe oxy-fuel is better because of the way the flame heats up the material, but it's not good, right? So I would kind of disagree with the question just as a premise anyway. What treatment is recommended after welding stainless steels? No heat treatment and no treatment is required for stainless steels. Quench in water to remove oxides. Well, that's just never a stated thing to do. Apply a pickling paste. Okay, so pickle and passivate. What that's going to do is stainless steel is stainless because of the oxide layer it produces on the surface of the material. So if you're going to weld and drop something straight into production or very quickly into its service life, pickle and passivating would be a good idea to do, and that would stop the rusting of the stainless steels. Super duplexes and that need it as well. However, they will naturally reform the oxide layer. It takes a bit of time. Oil to stop the rust. Well, it's stainless steel, so you wouldn't oil it. So let's go with pickle. Add a pickle and paste. Great. After welding, it is recommended to apply a pickling paste. This is because a welding stainless steel can form oxides. Yeah, great, which lead to corrosion. Read that again. This is because welding stainless steel can cause the formation of oxides on the surface, which can lead to corrosion. Applying the pickle paste helps remove these oxides and restore the stainless steel's corrosion resistance. Yes. It is an effective treatment method to ensure the longevity. Okay, right. Happy with that. How would you prepare heavily rusted mild steel for welding? Wash it with soapy water, grind back to bare metal. Wouldn't do anything, I'd just weld over it. I'll give it a light sand with 240 grit sandpaper. Well, we're going to grind back to bare metal, you know, a couple of inches back so we don't interfere with the weld at all. Yeah, necessary to bang back because of rust. Yeah, the rust will interfere with the weld pool quality. What are the 2 items a MIG welder that would need to be changed when changing from a 0.9mm wire to a 1.2? We would need to change the contact tip and the rollers. So we've got, there you go, just because it's a different size of wire. If the contact tip is too big, you won't have a contact, an electrical contact between the welding machine and the wire. And if the rollers are the wrong size, well, your wire will just slip. Stick or arc welding uses coated electrodes. What is the purpose of this coating? Well, we know from some of our other videos on the channel, an MMA electrode flux covering is there. It provides a shielding gas. It has alloying content within it, and it has bulking agents and helps form a slag and all that type of thing. So let's go. It insulates the weld from electric shock. No. The coating helps clean the weld from contaminants such as rust or paint. No, but it does have deoxidized agents in it which might clean up the weld pool a small amount. The coating prevents water from damaging the electrode. No. And the coating provides a protective gas to prevent porosity. Yeah, it does other things, but that's the right answer. Great. What is the minimum recommended filter shade on a welding helmet to protect your eyes? So in arc welding, you would go with shade 10 as a minimum. Personally, I find that's a bit light and my eyes start to hurt relatively quickly. I would use up to a 13. I just like it a bit darker. But minimum is a shade 10. Yeah, I've got that right. Why shouldn't you wear nylon clothing when welding? Well, they're flammable and they'll burn, so we don't want it. So because it can catch fire easily and melt to your skin, yeah, it's like it becomes like a hot plastic, doesn't it? And it's going to hurt you. So we'll go with that. Still see a lot of people wearing the wrong clothes when they turn up to our courses and wonder why that, you know, they'll turn up in their best hoodie and they melt. And it's like, well, come on, you know. There's overalls and old, you know, old stuff underneath those overalls is good. How would you prepare a 25mm low carbon flat bar for a butt weld? So, right, so we're talking about a penetration. So how do we prepare the welded joint? So give it a quick grind and make sure it's clean. Well, that's one of the things. We're going to, like the other question asked, we're going to machine back to bright metal, you know, grind back to bright metal. Grind a single bevel preparation, do nothing, or grind a double V preparation. Well, it depends, doesn't it? Do you have access to both sides? If I've only got access to one, I would give it a clean back at least 2 inches from the weld zone and then prepare my single bevel. Or if I had potentially both sides access, you could do double V. But we don't really have enough in the question to say what we're looking at. So I'm going to say well, it can't be two answers. Do I say the best one for welding quality would be a double V, because I could weld from one side, grind back on the other, maintain my penetration, bead, make sure there's no rubbish, I've got full fusion, and then weld back out from the other side? We'll go for that and we'll see what happens. Okay, so they've got that. Okay, there's an answer. We've worked it out. The question should have a little bit more detail in it. And would in a C-SWIP exam, say, they would give you, how would you, what joint preparation would you use on a 25mm carbon manganese steel joint when you have access from both sides and you're worried about root pen, something like that, What else we got? What type of respiratory protection is the minimum required when welding? So you'll see a lot of people not wear any protection at all. Dust mask isn't enough because that's not taking out fume. No protection is required. Well, it is. You should really be wearing a respirator plus local extraction and LEV. So I go P2 respirator. There we go. Yeah, hazmat suit. Not normally, but there are conditions that you might be in where you need it. Okay, so I've got that right. What type of weld would you do to form a T shape between two pieces of flat bar? So this is a fillet weld when the two parts come together. Yeah. Should we go? Yeah, for that. Most common type of joint there is. What is an inert gas as used in metal inert gas welding? So a gas that cools the weld zone to prevent cracking. Well, no. If you look at our hydrogen-induced cold cracking live stream we did last week, anything that cools the weld zone particularly quickly is going to promote cracking, and that's not what we want. A gas that prevents porosity by burning is a hot neutral flame. Clues in the title, it's inert, so it shouldn't burn. A gas that does not chemically react with other elements and helps produce a quality weld. Okay, maybe not the best wording, but we'll keep that in mind. And the last one, a gas that heats up the weld zone to create a better weld. Okay, so we'll say no, it's not that. So the best answer at what we got is C, the third one. But maybe you could reword this and say a gas that does not chemically react with the weld arc, and that's it. Yeah. If I was writing an exam, I just wouldn't go near it because it's quite hard to word out properly. But the answer is there. When performing a fillet weld between two pieces of 5mm thick mild steel, okay, what is the recommended leg length of the weld when the size is not given? So what we're looking for here is when you don't know what your material, what your weld size should be, you look to maintain the thickness of the plate material through the weld. And that means we could make a throat thickness of 5mm. Throat thicknesses are difficult to measure, or more difficult to measure than leg lengths. But the question is asking for the leg lengths. So here we need to look at a very quick equation, which is how we measure leg length to throat thickness. Because it's a triangle, leg length, I'm going to write it down as I speak. So leg length is equal to throat thickness times 1.4 times 1.4. Right? So leg length is always bigger than throat thickness. If we were trying to go the other way around, we would do throat thickness equals leg length times 0.7. So if I just quickly open my calculator on my phone. Dyslexic Geordie should always check maths on YouTube before it's recorded. So we're going to go 5 times 1.4 equals 7 mil. Now I haven't got an answer. Why not? So my leg length should be 7 mil to give me a throat thickness of 5 mil, so I maintain my thickness all the way through. A 7.5, but 5 times 1.4 is bang on 7 millimeters. So we don't have an answer here. I'm going to go 7.5 because that's the nearest one to my answer. And I got it wrong. Why did I get it wrong? When performing a fillet weld between 2 pieces of 5 mil thick steel, the recommended size leg length is 5 millimeters. No, it's not. This means that the leg length for each leg of the weld should be 5 mil. No. A fillet weld gets its strength from its throat thickness. So if you produce a 5 mil leg length, right, your throat thickness there, so 5 times 0.7 would be 3.5 millimeters. So what's that? Like more than, well, it's a third less so of strength because it's dropped that thickness. So I would disagree with that. I can see one person said they don't like the question. 23 people said they like it. So can I say what to do? What is the issue? How can it be improved? We'll do that later. But yeah, I disagree with it. It's here for posterity that I disagree with it. Always maintain your material thickness until the weld becomes too big that doing that is crazy. Then you would use engineering calcs to work out how big the weld needs to be. Which of the following is an advantage of MIG welding? It works well in the wind. You can weld safely in wet conditions. We're obsessed with wet conditions here, aren't we? It takes less operator skill than other weld types. It is slow and accurate, which is good for thin metal. Well, that's TIG. The last one is TIG. I'll go up here. Yeah, the last one's TIG. It takes less operator skill is true because what we're dealing with is a semi-automatic welding process. So the welder does not control arc length like they would in TIG or MMA. So I'll go with that one being the answer. And our last of the 14 questions is, if you found a tool to be faulty or dangerous, what should you do? Well, we'd take it out to service and we would report it, quarantine it, have maintenance look at it and fix it before we reuse it. So hopefully that's there. Right, there we go. So it's saying here I got did I get my certificate? Yeah, 93 out of 100. So we got one wrong, which is the fillet weld size, which again don't agree with. As someone who designs welds, I would always go with material thickness needs to be maintained, and we go from there. So that is another quick look though at a set of questions which are available online. It's great that these are here, but interrogate them. Just try to work through what you believe the logical answer should be, and don't just take what these multiple choices say is the answer being correct. And that's that. So hope to see you in the next one, and good luck with your studies.